As services become more varied and people seek greater convenience, modern social infrastructures are undergoing digital transformation. But even as people enjoy greater convenience in everyday life, inexplicable problems with electronic devices are increasing due to cosmic phenomena. This prompted NTT Laboratories to take the initiative in laying down international standards at the ITU for the reliability of communication devices against electronic problems caused by cosmic phenomena. These problems, due to cosmic phenomena, are caused by cosmic rays flying around in outer space, which collide with oxygen or nitrogen nuclei in the atmosphere, generating various particles. Among these particles, neutrons have particularly strong penetrating power and can pass through buildings. When a neutron collides with a semiconductor in an electronic device, the impact can temporarily rewrite data stored in it, causing a malfunction. This is called a soft error. Recent progress in integration and microfabrication technologies has resulted in dramatic increases in the occurrence of soft errors, as opposed to hard errors in which semiconductor devices are permanently disabled. In order to build highly reliable networks in response to this situation, discussions were held at the TTC with system and semiconductor vendors. As a result, 5 recommendations for standards regarding soft errors were adopted in November 2018 by the ITU, a United Nations specialized agency for international standardization of information and communication technologies. The recommendations included an overall recommendation regarding the issues, a recommendation on the method of estimating the rate of soft errors and the method of designing communication devices to deal with them, a recommendation on the method of testing soft errors by reproducing them using an accelerator-driven neutron source, a recommendation on reliability requirements against soft errors necessary in the building of highly reliable networks, and a recommendation on the method of evaluating the results of soft error tests to determine whether devices are up to requirement. These were the 5 recommendations. So, what was the concept behind the requirements that were laid down? The integration of semiconductor devices has caused a dramatic increase in soft errors as opposed to hard errors. But unlike hard errors, countermeasures against soft errors make it possible to greatly reduce troubles. This led to the laying down of various goals so that the rate of breakdown replacement and main signal loss caused by soft errors would fall to within the statistical error range of problems caused conventionally by hard errors. However, depending on the type of soft error, there is the rare possibility of a silent error for which malfunctions cannot be detected. Because silent errors cannot be permitted to occur, a reliability requirement was set so that it would not occur even after exposure to a neutron beam equivalent to 10,000 years of irradiation in the natural environment. 3 reliability requirements to mitigate the rate of breakdown replacement mitigate the rate of main signal loss, and prevent silent errors were laid down, and classes were set for each requirement. Fulfillment of these requirements will ensure reliability when building major networks. So, how are evaluations actually carried out? Tests and evaluations can be carried out through neutron irradiation tests using a compact accelerator-driven neutron source. In this test, devices are irradiated with neutrons at several million to several hundred million times the power they would encounter in the natural environment, allowing soft errors to be reproduced in a short time. First, exposing neutron irradiation to the device causes a soft error in it. When the state of the main signal and warning alarm have been verified, the phenomenon is classified into the 3 reliability requirements. The method ascertains whether the device satisfies the requirements by converting the irradiation time into operating time in the natural environment. This has enabled the examination of countermeasures and the rate of soft errors, which until now were difficult to reproduce. These recommendations will eliminate troubles caused by soft errors and allow the building of highly reliable networks throughout the world. Furthermore, it is believed that building on these recommendations will contribute to the solving of a variety of soft error issues in electronic devices, which are assumed to occur throughout the world in the future. NTT Laboratories will continue working with everyone to ensure greater safety and security throughout society.